Hello mathematicians, thank you for joining me today. What we're going to do is we're going to look at the vector space of continuous functions over the interval 0 to 1, and we're going to define an inner product between two functions as given by the integral from 0 to 1 of f of x times g of x dx. Then what we're going to want to look at is what is the magnitude of different vectors, what would the inner product of two vectors be, what would the angle between vectors be, and so that's where we're headed. Alright, for our first example, we're going to find the norm of f, where f is the function x plus 1. So now when dealing with inner product spaces, what we know is that the norm of a vector is going to be the square root of the inner product of the vector with itself. Now, since on this vector space we define the inner product to be the integral, what we're going to get is this is going to be the square root of the integral from 0 to 1 of f of x times f of x dx. And so if we substitute in what f of x is, we're going to get the integral from 0 to 1 of x plus 1 squared dx. So now that's what we would get using the definition of norm on an inner product space. And so the last thing we have left to do is just calculate this. So in order to calculate this, we would find an antiderivative of x plus 1 squared, which is just going to be x plus 1 cubed divided by 3, and we would evaluate from 0 to 1, and again we are going to take the square root of the whole thing, so we're going to get the square root of, well, if we plug 1 in, we get 1 plus 1 is 2, cubed is 8, so we get 8 thirds, and then we'll subtract off what we get if we plug 0 in. So that's going to be 0 plus 1 cubed is 1, over 3 is 1/3. So what we end up with is that the norm of f is going to be precisely 7/3. Now, for our next example, what we'll do is we'll let g be the function 3x plus 1, and what we want to do is we want to find the norm of g as well. So in order to find the norm of g, we call this is the square root of the inner product with g with itself. So that is, in this case, it's going to be the square root of the integral from 0 to 1 of g of x times g of x with respect to x. So that's going to be the square root of the integral from 0 to 1 of 3x plus 1 squared dx. Therefore, if I now want to find the antiderivative of this, what I can do is use my integration techniques. And so I'm going to have the square root of, and so what I'll get is 3x plus 1 cubed. Now if I actually take the derivative of this, notice that would be 9 times this, so I have to divide by 9. And so then I'm going to evaluate from 0 to 1. So my antiderivative is 3x plus 1 cubed, all divided by 9. And then I evaluate from 0 to 1, which means I plug 1 in. So I get 3 plus 1 is 4. 4 cubed is 64. So I get the square root of 64 divided by 9 minus, and if I plug 0 in, I get 1 cubed is 1 over 9 is 1/9. So in the end, what I get is the norm of g is the square root of 63 divided by 9. Alright, now that we've found the norm of f and the norm of g, what I'm going to try to do is find the inner product of f with g. And so to find the inner product of f with g, I'm going to integrate from 0 to 1 of f of x times g of x dx. And so that's just going to be the integral from 0 to 1 of x plus 1 times 3x plus 1 dx. Now if we go back to our integration techniques, the easiest way to do this is going to be to simplify. So I'm going to distribute out these terms, and I'm going to get the integral from 0 to 1 of 3x squared plus 4x plus 1 dx. So now I just need an antiderivative. So the antiderivative of 3x squared is x cubed, and the antiderivative of 4x is 2x squared, with the antiderivative of 1 being x. So I evaluate from 0 to 1. If I plug in 1, I get 1 plus 2 plus 1. If I plug in 0, I get 0, so I would subtract off 0. And so in the end, what I get is the inner product of f with g is 1 plus 2 plus 1 is just 4. Alright, the next thing we want to find is the distance between the vectors f and g. And so remember that the distance is defined as the norm of f minus g. So if I take the difference and find the norm, I will get the distance between the two vectors. In this case then, I'm going to get that this is the inner product of f minus g with f minus g. And I'm going to take the square root to get the norm. So to get the norm, remember, was the square root of the inner product with itself. And so we plug f minus g into both. And so this is going to give me the square root of the integral from 0 to 1 of f is x plus 1 minus 3x plus 1 squared dx. Because I would take f minus g times f minus g. It's just x plus 1 minus 3x plus 1 times itself, so I square it, and then I integrate from 0 to 1. Now, in order to integrate this, it is going to be easier just to simplify this. So notice that x plus 1 minus 3x plus 1 is going to be negative 2x. Negative 2x squared is just 4x squared. So this would be the integral from 0 to 1 of 4x squared. So therefore, if I want to find this distance, I would integrate 4x squared, and I would get 4/3 x cubed. Evaluate from 0 to 1. So I would get the square root of 4/3. Because I plug in 1, I get 4/3 minus plugging in 0 is 0. And so what we get is that the distance between these two functions is going to be the square root of 4/3. As our final example, what we want to do is we want to find the angle between these two vectors, or that is the angle between f and g. And recall that we define the angle by saying that cosine of the angle between them is going to be the inner product of f and g divided by the norm of f times the norm of g. Notice that we've actually found all of these already, so all we're going to do is substitute in what we found earlier. And we said the inner product of f and g is 4. The norm of f we said was the square root of 7 divided by 3. And the norm of g was the square root of 63 divided by 9. And so what we get is that cosine of theta is equal to 4 over the square root of 7/3 times the square root of 63 over 9. Now, since I wanted to find theta, I'm just going to say theta is our cosine of 4 over the square root of 7/3 times the square root of 63 over 9. And so my angle is just going to be the arc cosine of this value. Now, I can simplify this, and it does actually simplify fairly nicely, but I don't have to because that is my answer. I know that that is a correct answer, and that gives me my angle. Thank you for watching. As always, I hope you learned something today, and I hope you enjoyed the process along the way. If you did, make sure to like the video and subscribe to the channel. It helps me to know which videos are helpful, and it helps other people to find these videos so that they can also get help. Thank you.